Welcome once more to my COBOL course. We are looking at the B side to chapter 5 of this course, where we learned about file handling in COBOL. And here I want to emulate writing a file stream in COBOL. A file stream is a mechanism to read chunks of data from a file over time, and you do not have to read all the data, all those chunks at the same time, but that can happen distributed over different points during your program execution. The chunks that you read can have different sizes for the different read operations that you perform, and subsequent read operations will continue reading where the previous read operation stopped. So here I have a graphic display of this. So we have our file, we have some memory, and we use the open command to access this file here. And so the internal position in the file will point to the beginning of the file. And then we use the read instruction for our file stream to read 3 bytes or 3 chunks of data from this file. And we provide a buffer in memory where we want those 3 chunks of memory written. So let's say this is here. And in doing so, the internal position of the file gets moved forward by as many data chunks, as many bytes that we've read from the file. Then, at some later point, we can perform another read operation. This time we read 2 chunks of data, and we write it to a different buffer, buffer 2, which is located here in memory. And again, we move the internal position of the file forward by the amount of data that we've read. Then we perform another read operation. We read 4 chunks of data, write it to buffer 3. And we see those buffers, they can be anywhere in memory in principle. They do not have to be attached to one another or form a consecutive piece of memory. Of course, you could do it that way, but you don't have to. Again, the internal position of the file is moved forward by the amount of memory that we've read. Next, we close the file, so the internal configuration of the file gets forgotten. We do no longer have some internal position associated with it, but the data that we wrote to memory, that we took from the file, still persists in memory. COBOL does not offer such a file stream functionality. If you remember the chapter 5 of my course, then you might think that sequential files more or less do what we just discussed, and they are indeed the closest thing that we have to file streams in COBOL, because they do read chunks of data one after another, and they do remember the current position in the file. But there are some shortcomings of sequential files which do not make them proper file streams. First, we cannot read chunks of data of arbitrary size. So the size that we read using a sequential file in COBOL is fixed by the record, by the data structure that we assign to this file in the FD statement. Now, even if the record we assign to the file contains entries of variable size, then you may recall, even for those, we have to provide an upper limit for the size. So the size can be variable, but the size cannot be arbitrary. In particular, this means it is in general not possible to read data from a file whose size will only be determined at runtime. So this is really a problem, in my opinion, that COBOL files, the built-in file mechanisms, cannot handle. And also we cannot provide different buffers to receive the data read from the file, because in COBOL file operations, the data is always written to the record that is associated to the file, the one associated in the FD statement. And that's the reason why I want to emulate file streams in COBOL. The idle we are trying to emulate is C's fread function. So this is what it looks like, fread with 4 arguments. I just omit the type definitions because they would not be very helpful here. But if you use man fread in your terminal, then you get the full documentation of this function. Now the arguments are as follows: ptr, pointer, the first argument, points to a buffer in memory, and this is the one where we will write the data that we read from the file. Size is the number of bytes in each element that we read. So we assume we read data of a certain type, which has this given size. N items is the number of elements to be read, so the number of the elements which have this particular size. So the number of bytes that we will read in total will be size times n items. And finally, stream is the final handle to the file that we wish to read from. And the return value from this function is the number of bytes that were actually read by fread. Now I want to implement a COBOL subprogram, fread_cob, that more or less emulates this fread_c function, but we will have to do with certain restrictions. The idea in general is that the subprogram uses a sequential file whose record consists of a single byte. Then it wraps around repeated read instructions for this sequential file, where in each instruction we read 1 byte from the file. So this will be done in a loop, and this will be written to an output buffer, which is different from this single byte. And to simplify things a little bit, I will only accept the number of bytes to read and not these two arguments here, not a size value and a number, but rather just the number of bytes. So if you want to read elements of a given size, you would have to compute how many bytes that are before calling fread_cob. Our subprogram fread_cob should accept 3 arguments. The first one being buffer. This is the buffer in memory that will receive the data from the file. Now, there's a limitation here in that COBOL does not provide dynamic memory allocation. So this buffer has to be pre-allocated and must be of a fixed size that is known at compile time. So we must provide a reasonable size for this buffer to begin with. And I just pick 4096 bytes or 4K bytes. I just chose this because 4K bytes is the traditional size of a page in memory, but what is reasonable might vary from whatever application you have in mind. So this is just an example because I had to pick something. Now, the downside to having this limitation is that if you want to read X bytes from a file and X is larger than 4K, then you have to split this over multiple calls to fread_cob. And to make this more precise, if X is the number of bytes we want to read, then we can write X as a multiple of 4096, so n times 4096, plus some remainder, where the remainder is between 0 and strictly less 4096. And that means we need to make n calls reading the full 4K bytes, and then 1 call reading the remaining R bytes. Unless R is 0, then of course we do not need to make a call. The second argument for fread_cob is n bytes. So this is just the number of bytes we wish to read. And by the discussion above, clearly this must be between 0 and 4096. If we wish to read more bytes, then as I said here, we have to split this over multiple calls. Third argument is source file, which is a string, and this has to be the system name of the file from which we want to read. And it has to be the system name because we cannot pass the internal file name of the calling program to the subprogram. So this will be the name of the file as it is saved on disk in the operating system. In conclusion, this is what the linkage section of fread_cob should look like. Source file, the name of the file we want to read from, n bytes, the number of bytes, and the buffer we want to read into. So let's start writing our subprogram with this linkage section. So here I have the outline of fread_cob, already the comments on what arguments we will use. And in the data division, I have to implement the linkage section. First I write the name of the file. Let's allow this to be up to 255 characters long. Then we have the number of bytes we want to read in one call. Let's just allow a large number for that. And we define it as binary. And then our buffer, which I will define as a record with an array in it. And I fix it to be of size 4K. Of course you can change this, but you have to be consistent throughout the program to change this everywhere. And here in the procedure division, I already have the using clause, buffer, and byte source file. So these are our 3 arguments that are being passed to the subprogram fread cop. We want the file stream to be able to read from arbitrary files during the program execution, perhaps multiple different ones. So we have to declare the system file name as dynamic. And that has to be done both in fread cop and the program that will call it. So recall dynamic is the COBOL keyword, or the GNU COBOL keyword, that allows us to make the file name depend on a variable. Unfortunately, this is not available in all COBOL dialects. And in particular, it's not available in the IBM COBOL dialect. But in GNU COBOL, we can still use it, even with the IBM flag. This is what it will look like. The environment division, input-output section, file control. Here we assign our internal file to the system file, but due to the dynamic keyword, we can put a variable here instead of a fixed file name. And this goes to the environment division. Input, output, section, file control, select, let's call it stream file, and we assign it to a variable that we name source file. If we want to use the file stream properly, we must be able to open and close it in the main program and not actually in the subprogram fread cop, because if we did that, if we opened and closed it in fread cop, then every time we call it, we would lose the current internal position in the file, and that would make it completely useless. So it's important that after each call to fread cop, we retain the current internal position in our stream, and therefore we have to open and close the file in the program that actually calls fread cop. Now the question is, can we pass an already open file to a subprogram in COBOL? And that is actually very simple to do in COBOL. So all we have to do is to assign the record that we assign to our internal file as external. And that will let COBOL know that a file by this name will refer to the same file in different components of the program. So in the subprogram and in the main program. And this will just look like this. In the file section, in the FD statement, we add the keyword external, and otherwise we do everything as we would usually. And for our file stream, as I said before, we will just have a single byte to read. And the reason that we just define a single byte as the data for this file is that we want to have complete control over how many bytes we read by making precisely as many calls to the read instruction within fread cop. Now let's include the file section in the data division. FD for stream file, and we declare it as external. And now we assign our single byte data structure to it. Now we get to implementing the program logic. So in the procedure division of fread cob, first we'll do a check that the number of bytes we're supposed to read is not larger than the buffer size. So this is this block. And then we implement the stream by looping from 1 to the total number of bytes that we're supposed to read, and in each iteration we read from the stream file, and we will be reading exactly 1 byte in each iteration. And then we're done. So let's implement this, and I will comment a little bit more on it. Let's get started with the procedure division. I just copy in the check that we are not reading more bytes than we are allowed to. So if the number of bytes, n bytes, the parameter is given is greater than 4096, then I'll display this error message that we cannot read more than 4k bytes at a time, and exit program will return from the subprogram to the main program. Now assume we have legitimate parameters given, then we perform the loop. I will use tally as my loop counter, varying it from 1 by 1 until tally is equal to n bytes plus 1. Now you have to use the plus 1 here because the loop condition is checked at the beginning of the loop. So if I want to read n bytes, then I should still execute the n bytes iteration, and only after one more iteration, after this, the n byte operation has been done, only then should I terminate the loop. So that's why I had the plus 1 here. All I need to do is read stream file, but I want to have some control if I reach the end of the file, so I will just exit program. That is return from the subprogram to the main program. And the next thing is to move the stream byte that we read to our target buffer. So this read operation here will read into this data structure. So we will read 1 byte here, and this byte will now be copied at the appropriate position into buffer. The position we know from tally because this is our counter, so we'll use this as an index. And that's that. Now this looks reasonable, but it's not going to work because, well, I can't use periods within the perform loop because any period would signal to the perform instruction that the loop would be at an end here. So because I can't use a period after this exit program, COBOL will interpret everything coming afterwards as belonging to this at end clause. So this would actually only be executed if I reach the end of the file, which makes no sense. So I could either make an explicit end read statement here, following the read, to tell COBOL the read statement is over and this is to be executed independently of the read. Or what I can do and will do now is I use the not at end statement for the read instruction and perform my move within this not at end clause. And that's all. Next, we're going to write a main program that will use fread corp to read bytes from a file. And in this main program, what we will do, we will ask the user to enter the name of a file that we want to read from, and then enter the number of bytes that we want to read from that file. Now, COBOL is a bit special in handling files and subprogram. So due to that, we have to replicate some of the information from the subprogram fread cob in the main program. So that is something you have to be aware of when you use this, that you actually need to look at the subprogram here and copy some of the information to your main program so you can actually make a sensible call. First, the assignment of the internal file name to the dynamic system file name given by the string source file must be replicated in the main program. We must replicate the fd statement that defines the record for the file, including the external keyword. And we must declare the string variable source file in the working storage section that will hold the dynamic file name that we want to read from. So this is what this would look like in our calling main program. So let's start implementing the main program. Here I have the outline of the main program, so you can see already in the procedure division I have the input from the user where you can enter the name of the file you want to read and the number of bytes you want to read, and after that we'll have our program logic. And first I'm going to do the data that we take from fread cob. So first the input output section, file control, the same select statement that we had in fread cob. Then in the data division, first the file section where we assign our 1 byte record to the internal file name. And we declare it as external, so COBOL knows that it refers to the same file in the main and in the subprogram. And in the working storage section, we replicate the arguments that we pass to the subprogram. So first the string source file for our dynamic file name, again 255 characters long, and already I'll enter here a number n. That will be the number of bytes we want to read as a numerical variable. And I will declare a buffer that I want to have my data written into. I'll just call it my buffer. And this buffer can be of arbitrary size, so this doesn't have to be of the same size as the buffer in fread. And the idea is that we might have to call fread multiple times to fill this buffer or write to positions in this buffer. So I just pick 10,000 here. I actually found out that if I pick numbers too large here, then GNU COBOL will not play nice with that and the program will crash. So I don't know exactly what causes that, but just for the sake of demonstration, I will go with 10,000 here and that will work well. So this is more than twice as big as the maximum size we allow for fread cob to read. So if we really wanted to fill this buffer, we would have to use more than one call to fread cob. If we only wish to read a small number of bytes, that is less than 4K bytes into our buffer, then we would just use a simple call to fread cob using the call instruction with the name of our subprogram given as a string and using a buffer variable, the number of bytes n, and the source file name. COBOL uses call by reference as a default, so we will by default pass the addresses of these arguments to the subprogram. So any changes we make to these arguments will be returned to the main program. So we do not copy the data and change copies in the subprogram, but we make changes to the actual data that we pass from the main program, which makes sense because we actually want to write to the buffer that we have in the main program. And in that way, we can make sure this actually happens. So we do not have to use any modifiers to call by content, by value or something like that. Now, I noticed that in GNU COBOL, you get some error if instead of a variable n, you actually pass an immediate value. So if I would just write 4096 here as a number, then what I suspect happens, and I suspect that from briefly skimming through the intermediate C code that GNU COBOL generates, then instead of using the value, the constant 4096 as an argument, GNU COBOL will take the address of that number in memory and work with that. And of course it would yield nonsensical results in the computation. So to prevent that, I will always pass the number of bytes that I want to read in a variable rather than as a constant that I supply immediately here in the call. And recall what I just said before, that if we wish to read more bytes than 4K bytes, then we have to call fread multiple times in the main program, and each time write the data that we get returned from fread to the correct position in our target buffer. To do this, I define two numerical variables that I call rounds and remaining, such that n, the total number of bytes you want to read, equals rounds times 4096 plus remaining, where remaining is strictly smaller than 4096, but non-negative. What we do then is we run a loop, a perform loop, for rounds many iterations. So the number that we computed here in this way, this is the number of iterations we will perform in the loop, and in each iteration we will call fread to read the full 4 kilobytes. And that means in the ith iteration, those 4 kbytes will be written into the target buffer at the positions 4096 times I-1 plus 1 up to 4096 times I. And in that way, in each iteration, we will write a 4 kbyte chunk into the target buffer at the correct positions. Once the loop is over, so we iterated all the rounds, reading 4 kbytes in each, we still have remaining bytes left. So if remaining is larger than 0, we need to read more bytes, and we do this by calling fread once more with remaining as the parameter, so the number of bytes we read is remaining, and this will fill the positions 4096 times rounds plus 1 up to n in the target buffer, where n was the total number of bytes we wanted to read. And here is the program logic for this in COBOL. First, we have these two compute statements where we compute rounds as an integer division n by the maximum size of bytes to read. So this would be a variable holding 4096. And then we compute remaining as the remainder of this integer division. Then our first perform loop here would be the loop over rounds many iterations, where we call fread each time with the maximum byte size of 4096. Once this is done, we check if remaining is greater than 0, and in that case we do one additional call to fread where we read remaining many bytes. And notice that I introduced two variables, max length and max buffer, where this is simply a variable to hold the number 4096, because, as I said before, I do not want to pass this as a constant here, but rather have to write it into a variable and then hand the variable to the subprogram. Otherwise, GNU COBOL will not play nice and give me nonsense results. And max buffer is just an auxiliary buffer that is of size 4 kbytes that I will use to receive the data from fread cob, and then I will move the data from max buffer to my actual target buffer. First, I need to add my additional variables. So here's rounds, also a numerical variable. Same goes for remaining. And then IDX is just an index variable that I will use. This will help me address the right positions in the target buffer while I'm looping over the different calls to fread cob. Maxlen is just the variable I will use to hold the number 4096. And max buffer is the buffer of size 4096 that I will use as a temporary buffer to hold the data returned from fread cob. This is actually a byte buffer. Now let's write the actual code. First, I will supply an error check. So if the number of bytes I want to read is larger than the length of my buffer, so larger than 10,000, I will print an error. Of course, you can play around with this value here and change it, but we shouldn't try to read more than actually fits into our target buffer. And now we read from our file. I will first open the file. And remember, I said this is something we have to do in the main program. At the end we will close it, and in between these two comes our program logic. Don't start with perform, we start with compute. We compute rounds and remaining. Rounds is just the integer division of n by 4096, and remaining is the remainder of that integer division. Now we start the loop, varying tally from 1 until tally equals rounds plus 1. So again, I count up to rounds plus 1 because we check the termination condition for the loop at the beginning of the loop. So once I've done rounds many iterations, I'm done. So then I get to tally equal to rounds plus 1, and at this point I stop the loop. Call fread cob using the following parameters: max buffer, max length, so 4096 for kbytes in this loop, source file, and when we're done with the call, we compute the position in the target buffer where we need to write the data that we just read. So I compute the index as 4096 times tally, our counting variable, minus 1 plus 1. So plus 1 because in COBOL indices start at 1, not at at 0 like in many other programming languages, so this is why I have to add 1 in this iteration. And then with this index computed, we move the buffer that we just read with fread cob to our target buffer. Perhaps you recall this notation from the strings. If we have a string variable, my buffer, this one here, then we can actually access it using an index, so the position in the string followed by the length of bytes that this substring should have. So at position index we take the substring that is max length, so 4096 bytes long, and to this we write max buffer. And that is our loop. Once the loop is done, we check if we have remaining bytes to read. And if that's the case, we do one more call to fread cob. Using again max buffer to receive the data from fread cob. And now we don't use max length, but we use remaining as the number of bytes to read, and of course we read from the same file as before. Then we do the same computations as here. Compute the index where we want to write the bytes we just read. And then we move the intermediate buffer to our target buffer. Okay, that's all we need to do to read an, in theory, arbitrary amount of bytes from a file. In practice, this is limited again by the fixed number we supply here, but this one you can change as you like, as long as GNU COBOL doesn't crash your program if you go too high. And I will end this by actually outputting the bytes that we just read from that file, just to verify that everything worked as we expected to. So display the first n bytes of the file, and here I give the truncated source file name and then display my buffer. So here I just dump the bytes contained in our target buffer to the terminal. And that's it. Now we can check if this works. We compile this using this command here, copc -x -standard equal to IBM. First the main program, then the subprogram, and here the name of the executable file, which I just call stream. We do not get an error. That's a pleasant surprise. Let's call stream and see if everything works. Which file do you wish to read? Let's read stream itself. So that's a binary file, so we'll get a pretty weird output probably. How many bytes do we wish to read? Let's say 100. And the first 100 bytes of stream are these. Now we can compare this with the head command in the terminal, and this looks like the same. So these bytes here coincide with these. Let's read some more bytes. So let's read let's read 10,000 bytes. So here we have to do some loops and piece together the chunks that we read in each iteration. Yeah, that looks a bit strange, but it's a binary file. Yeah, maybe let's just compare this output with with the head output. Yeah, ignore this symbol here, that just comes from the head command. So yeah, if you compare this looks pretty much similar, and the beginning of the file as well, this and this. So yeah, it looks like we pieced it together reasonably, and this indicates that our file stream works. And if you found this interesting, then maybe you will find it an interesting exercise to write a subprogram fread cob that will emulate a file stream that writes to a file rather than reading from it. So in the spirit of C's fread function. Thanks for watching, and do not forget to like this video and subscribe to my channel. Bye!